Right, so example 5 has x plus 3 over x squared minus 1 plus 2 over x squared minus 3x plus 2. You're going to notice that x squared minus 1 does not match x squared minus 3x plus 2, so we don't have a common denominator here. So we're going to start by factoring. X squared minus 1 being a difference of squares is x plus 1 times x minus 1. The quadratic trinomial x squared minus 3x plus 2. We're looking for numbers multiply to make positive 2 that add to make negative 3. That'd be negative 2 and negative 1. Since we have a coefficient of x squared, that works that way. So it's going to be x minus 2 times x minus 1. And again, this is just a least common multiple of the denominators. So if I'm looking at the pieces that happen here, x minus 1 happens, x plus 1 happens, x minus 2 happens. And again, x minus 1 happens multiple times. Doesn't matter if it happens once, it counts once. So if it happens twice, it counts once. So least common multiple here is going to be the product of each of those pieces. So x plus 1, x minus 1, and x minus 2. And you can see the first power, first power, first power, first power, everything's first power, so I'm just going to keep first power. Now the next step in the least common multiple process is to multiply that together, but for the sake of what we're going to be doing right now, I want to keep it separated for now. Okay, so we're going to keep it separated in the factored form, okay, when we're working on our problem. So if I come over here and rewrite this problem, this first object is x plus 3 on top, and x squared minus 1 is the x plus 1 times x minus 1. I'm going to put the top in parentheses, and I'm going to extend this fraction bar a little bit, like so. Then I'm going to put plus, and then I'm going to put my second fraction, which is this one. 2 is on top, and on the bottom I've got the factored form, which is x minus 2 times x minus 1. Right? So I've broken down the denominators, so I've got them written in factored form. I've extended my fraction bars because I want to create a common denominator here, which requires me to put extra stuff on these fractions. So I'm extending the fraction bar to give me some room to put that stuff in there. And what I need to do is the quick inventory. This is what I want it to be, and this is what it is. Okay, so x plus 1 times x minus 1, I want it to be that. What's missing? X minus 2 is missing. So I'm going to put an x minus 2 on this denominator, which requires me to put an x minus 2 on the top. I look at the next fraction, do the same thing. I look at what the denominator is, right here, and what I want it to be right here, and see what's missing. So x minus 2 and x minus 1 are there. What's missing? X plus 1 is missing. So x plus 1 has to go here. I'm going to put an x plus 1 on top. That's all it is. That's how you make a common denominator. You find out what's missing, and you put it on there. So this is what you want to do. This is the consequence. This is what you want to do. This is the consequence. And again, what I want to do is based on what I want it to be and what's missing. So this is what it is. What's missing it is x minus 2 because that's what I want it to be. This is what it is. That's what's missing because that's what I want it to be. That's what your least common multiple is going to be every time, is what you want it to be. Once you've created the common denominator, now they're both x plus 1, x minus 1, x minus 2. The order doesn't matter about the pieces, but they have to have the same pieces. Once they're the same, now you have a common denominator. What's left to do now is to add the tops together. Okay, on top, I do have to multiply things together. So I got a binomial times a binomial. X times x is x squared. X times negative 2 is negative 2x. 3 times x is positive 3x. 3 times negative 2 is negative 6. That's being added, so plus, and then this is 2 times x plus 1. 2 times x is 2x, and positive 2 times 1 is positive 2. Again, this positive is attached to that 2 that's being distributed through. On the bottom, now I want to multiply that stuff on the bottom together. Right? I've created the common denominators. I've gotten everything as it is, so now when I want to multiply it together, I can either do it within the confines of the problem, or I can finish it up over here, take your pick. I'm going to do it over here so I have more room. I'm going to start with this product. Nothing special about that product. I'm just picking that because that matches that, which is equal to this thing over here. So x squared minus 3x plus 2 is being multiplied by x plus 1. And x plus 1 times x squared minus 3x plus 2 is just x times everything, which is going to be x cubed minus 3x squared plus 2x. And then 1 times everything, which is going to be plus 1x squared minus 3x plus 2. Like terms here and here. This has a 1 in front of it, so x cubed minus 2x squared minus 1x plus 2 is what all that comes out to. So x cubed minus 2x squared minus 1x plus 2. I just put the minus x instead of minus 1x. So the bottom's fixed completely. What's left to do on the top then is combine like terms if there are any. And you'll notice negative 2x, positive 3x, positive 2x are like terms. And negative 6 and positive 2 are like terms. So my end result on top, I've got x squared minus 2x plus 2x cancels, plus 3x leaves plus 3x. Negative 6 plus 2 subtract, the signs are different, and negative 6 is bigger, so minus 4. All over x cubed minus 2x squared minus x plus 2.